happy with that. This start of 5, actually 5 and 6, and I think 7 too, is all on, basically on, well, pretty much the whole rest of things actually, pretty much on polynomials. So 5.1, come on. Why is it not writing? .1, and oh, I don't know why it's not writing very well here. Let me thicken it up a little bit. Hang on. There we go. Okay, so it's on polynomials and basically performing operations on them, manipulating them algebraically. So today we're going to talk about adding, subtracting, and multiplying them. All right. So a polynomial, poly means many, and nomial means terms. So a polynomial is just a expression of terms, basically. So, for example, just x squared plus 2 is a polynomial. Okay, if we have x plus 4, that's also a polynomial. If I have a x cubed minus x squared plus x minus 1, that's a polynomial. Even the number 3 can be considered a polynomial. All right? So, anything that's written in that kind of form is a polynomial. So things that are not would be something like this. So when you have an x on the bottom of a fraction, then it's not a polynomial. Okay, you can't have that. Anything that looks like this, like a function, so like the square root of x, this is not a polynomial because it's in terms of a root. All right, so those would be considered not polynomials. But the rest of those things are. Okay? So polynomials can be named in a couple ways. And I'm not going to test you or quiz you on the name of a polynomial. All right? What I would like you to be able to, we're going to be talking that vocabulary, so you're going to know what it is anyway. But polynomials are named by their degree and by their terms. So most of the time in upper level mathematics, so you know, those you're going to be pursuing that, if you do that, they're named by their degree. You know, in this course, they're kind of named by their degree and their terms. So what do I mean by degree? Well, the degree is going to be the highest exponent or power, however you want to think about it, of a term. Exponent or power. And the terms is named by the number of terms. Number of terms. Okay? So for example, I'm going to do it two ways. I'll put degree here, and I'll put terms here. And we'll just start out with a simple one. X. All right? So that's just a first degree because the power on the x is 1. So we call that a first degree polynomial. Not very often, though. And it's just a monomial because mono means 1. If I go like this and I have x squared plus 3, then this would be a second degree polynomial because the highest power on it is 2. Does that make sense? It has 2 terms, so it's called a binomial. Binomial means, bi means 2. If we have x squared plus x, let's actually make this an x cubed just for the kicks. X cubed plus x plus 4, all right, that would be a third degree polynomial because the highest power is 3. And this would be called a trinomial because tri means 3. All right. And that's kind of how they're named. Now notice also that when you write polynomials, you want to try to write them as the highest power first. We call that descending order. So here we went 3, 1, and this doesn't have a power. 2 doesn't have a power. So you always want to start with the highest power first when you're writing them and writing them in descending order. It's going to help you a lot later on. Now, I've never heard anybody say quadnomial. Doesn't happen. When they get to that point, they're usually named after their degree. Okay? So if we had an exponent of 4, that'd just be a 4th degree polynomial. That's what we would call it. Okay? So this is by the number of terms. So I could have a trinomial that looks like this, x squared plus x minus 6. This would be a second degree, but it would be a trinomial because it has 3 terms. Okay? 3 terms. 1, 2, 3. That's called a term. Again, that's not anything I'm going to test your quiz you on. All right? But we'll just be talking that vocabulary. So I'll say, wow, this is a binomial. Oh, that's a trinomial. Okay? So we'll just be talking about them. Questions on that? It's pretty.
So you said if there was like 4, 5, 6, 7, whatever, etc. degree, then we would just write the number and then the movie, right?
So if you had like an x to the 7th,
yeah,
then it would be a 7th degree, right?
So how would you write the term?
Well, how many terms does it have? It depends.
Oh, okay. So it's the degree that you write down.
Right. Okay. So, let's see. They're going to ask you to add and subtract these. All right? So let's do that. Adding and subtracting means you're going to do this. Like terms. I'm almost sure you do some of this in Math 60, so this isn't going to be anything that is going to be really earth-shattering for you. So, like terms is the key thing. So here's a polynomial here. I'm going to go 2x plus 5. And I'm going to separate them by parentheses. Okay? So there's 2 polynomials. I'm going to add them. So I want to make sure I add up the like terms. So this is a like term. And this is a like term. So I have 2 plus 3, that gives me 5x's. 5 plus a negative 8 gives me negative 3. There it goes. I just added up now. I took 2 polynomials, added up, got it. There it is. All right. All you got to do is add and subtract your like terms. Okay? When you're adding and subtracting polynomials. But you got to know what like terms are. So if we have 3x squared minus 4x plus 8, so that would be 1 polynomial plus 4x minus 7. That would be another polynomial Going to add up the like terms. 3x squared. Do I have any x squareds in the other one? Nope. See how I'm always starting with that highest power first. Okay? Always starting with that. So I want to write it in decreasing order. It's going to help you a whole bunch when we get to the next chapter. Negative 4x here and a 4x here. Oh, what happens to those? They cancel out. Well, that's not too exciting. 8 plus a negative, or plus a negative 7 or minus 7, however you want to treat it. That's just going to be 1. Okay, there's my answer. So I'm just looking for like terms. All right. They can use y's too instead of x's. Bless you. You're welcome. It doesn't matter whether they use x's or y's or x's and y's. Okay? You're just adding like terms. Oops. So here we're going to get 9y squared. And then let's see, we got a plus y, plus 3y. Again, I'm starting with that highest power, working my way, minus 19. So that would be a trinomial. Now let's do a subtraction one. Okay, combining like terms again, x squared, x squared. So I like to have, when I was doing this in 60, I say you got to read it. So this has 3x squared minus x squared. So that's going to give me 2x squareds. 4x's minus a negative 3. So that becomes a positive 3. So that's a 7x's. And negative 10 minus 1. Right.
Okay, so are you talking about 4 plus 4x minus, the minus and the plus 4 becomes now, how do we get the?
Because this minus
Oh, that
comes
minus
through
and minus
here, and
distribution.
here, and here, because you're minusing that whole quantity. Okay.
Oh, then the 3, negative 3x becomes positive 3.
Yeah.
And that's why you got 7.
Yep. Yep. Okay. Let's see. What did I get? Let's see. 33 odd. And no. 9 through 32. 55 through 70. Okay. So if you look on page 354, all right, what I did for your assignment was I completely skipped the ones that they write them in vertical format, because this is like the only book I've ever really seen write them in vertical format before. So I just basically skipped those parts. All right.
What page was it you said?
354, 355. All right. I think I tried to stay away from the fraction ones too, just because I thought that was kind of a waste of time. But you can see there, you're just adding and combining like terms, right? Okay. You see the vertical ones? I just dumped those ones. Yeah, so don't do that. Make sure you, yeah.
Can we do one more subtraction just for safe measure?
Yeah, we can do as many subtractions as you want.
So, on page 355, number 55 to 70, you said you want us to do it or you don't?
What's, no, I was just saying that you see all the ones that are written in a vertical format? 38 through 54 ones? You see those ones that are written in a weird, different format?
Yes.
Oh,
That's
yeah,
vertical.
decimal.
No, just in the way they're written.
Yeah, the way of it.
Yeah, we just skipped all those because I've never seen any book really do that.
Oh, okay.
Okay,
Okay.
yeah, so if you're wondering, that's why I did it. Just, I don't know why, usually they're written in this format, so. Okay, here we go. So common terms. I got an x cubed here. And then we have a minus, so this minus is going to distribute inside to each one of these. So we're going to have a 5x cubed minus a negative, so that's going to become positive. So how many x cubes do we have? So we have 7x cubes. All right, then we've got a 4x squared. Oh, do I have any x squareds on the other one? No. Nope. So then I just bring this down as a 4x squared. Then I have an x there and an x here, but this is a minus. So I have a minus and a minus, so that becomes a negative 2x. And then at the end I have a 1 minus, that becomes a plus, so that becomes a plus. Yep. Okay? So there we're adding and subtracting them. Any other questions on those? Okay. That's 5.1. 5.2. Multiply them. And I think you've done this before too. Now there's a little bit of, little tiny bit here in this section on exponents. Okay? So I want to put a little slash here and call it exponents. All right, so let's talk about exponents. In fact, I think I'll just switch colors to red or something. Okay. There are things called the properties of exponents. And this I don't remember if you've seen this or not. I just don't. One of the basic properties of exponents is when you multiply terms that have exponents, you add them. And usually what I do is I talk about, okay, let's say we have x to the second, and we're multiplying that by x to the fourth. All right, if we understand the concept of powering, then that means this is an x times an x. And this would mean we'd have an x times an x times an x times an x. So when I'm all done, how many x's do we end up having? 6. Okay? So it really doesn't matter what these numbers are here and here. If I write them all out, I'm always just going to add those exponents. So if we have, say, x to the m times x to the n, then that means I'm going to have x to the m plus n. And I would just add the exponents because it goes back to this idea. See, to me, this is really important that you understand what powering means and the concept behind exponents. If you understand that concept, you can do any exponential problem you will have if you get that. Okay? Because you don't need to memorize the laws. You just got to understand exponents. And if you understand the concept behind powering, then you're good. Did they do this? I can't remember if you did this or not.
They told us that we couldn't, it has to be the same.
Yeah, the base has to be the same, right?
But the exponent could be different.
The exponents can be different, right? Yeah. Okay. So I wasn't sure that that was in there. I thought it was, but I wasn't sure. So this is like the first.
There's a question in the back.
Thanks.
The exponents only minor or atom when it's division.
When it's division? No. So let's look at that. So let's say we have x to the 6th divided by x to the 2nd. All right? So here I would have all these x's, 6 of them, and I'd have 2 of them on the bottom. Okay? And a lot of times when I'm doing these types of problems, this is what I would say. How many x's do we have on the top? Well, we have 6. Well, how many do we have on the bottom? Well, we have 2. What's going to happen to these 2 x's here? So you cancel and leave you with 4 of them, right? Oops. So, see, if you understand that, you don't have to know that the second property of exponents is if you divide, then you subtract the exponents. Okay? I mean, you can, like I say, when I do this, I tell people, you can memorize property and stuff in mathematics. So you can memorize it, and maybe you'll be successful. I don't know. But if you understand it, it's way better because then you don't have to memorize anything. All right? You can memorize stuff. You could go home and study for a test and then just memorize all the rules, and hopefully during the test you don't get all nervous and stuff and you remember the rules and laws. But if you understand it, then you can just do it.
And so for addition and subtraction, you don't add the exponents besides the base.
Well, now think about what you were doing up here. Okay? And you never see, people don't question that now. But look, this x squared here is the same as this x squared, and we just added it, right? We never touched the exponent. You understand that, right? I mean, I can tell you, well, there's a mathematical law that says, when exponents are the same, you don't have to add or subtract it, but you understand it. Oh, that's 3x squared minus 1x squared is 2x squared. So, yeah, we're just leaving them. You see what I'm saying? Yeah. So, nobody even questioned that. So then now we come down here and I say, okay, here's some properties of exponents. So when we multiply, we're going to add the exponents. And when we divide, we're going to subtract the exponents. Then there's laws of properties. Yes?
So say if it was like x to the 2nd power over x to the 6th power, would the answer be x to the -4?
Well, it could be x to the -4, which is fine. You can have negative exponents. Or it could be 1 over x to the 4. Because if you have, so we flip it. So let's say we got this. So that's x and x, right? And here we have more x's down here, 6 of them. 1, 2, 3, 4, 5, 6. So these guys are going to cancel. And now we have 4 x's on the bottom, but we have a 1 on the top. So it'd be 1 over x to the 4th. Yep. But our properties of exponents would say it would be 2 minus 6, which is -4. Yeah.
Because there's no negative exponents.
There are negative exponents.
There are? Oh,
Uh-huh.
okay.
Yep, there are negative exponents. I don't know when, that doesn't come up here. I'm not sure when you pick up negative exponents. Someplace along the line they're going to show up. I'm not sure where.
Basically, a negative exponent would make it 1 over whatever it is.
That's the law.
Yeah.
Okay.
Yep. And then they usually say to write things without using negative exponents, right?
Yeah.
Yeah, okay.
Okay. Sure. Oh, there are negative exponents. Just, yeah, you're right. Okay, so the other thing they want to talk about in here is what if we have x to the second to the third? Okay, so then that means conceptually we'd have x times x, but we'd have that 3 times, because that's what that means. So in that case, how many x's do we have all total? 6. So the property of exponent says, and this is the third one, then if we have x to the m to the n power, then we would multiply those numbers. All right? So when we're raising to a power, we multiply the exponents. But again, if you understand what this means that I have x to the second grouped 3 times. Oh, that's 6 of them. Okay.
So then the x to the m power, that one, is it x m negative n?
No, it's m times n.
Oh, times.
I try to put a little dot there. So you're just multiplying it. And the problems you're going to do, this isn't going to be issues because it's going to make sense to you. You watch. When we start multiplying these things, it's going to make sense to you. You're not even going to think about these properties. Okay? You won't even think about them. Yeah.
So what happens when like you have say 9x squared plus 9x cubed? You can't have them measured at the same point.
Did you say plus?
Yeah. Or
Is that what you're asking me about?
yeah.
What happens there? Nothing. They're not like terms.
Oh, the exponent?
Yeah. Exponent makes them unlike. That was the same thing up here when we had, where was it?
Below it, that one.
Yeah, because we had a 4x squared. See here, right here, 7x cubed plus 4x squared. Can't combine it. Can't do it. They got to have the same exponents to combine them. Don't let the exponent stuff throw you too much. Whew. Okay. Let's see. I don't remember what color it was. I'll just go back to this. All right, so now let's actually apply some of this stuff to multiplying them. So let's start off with something like this. So we're going to go 3x times x plus 5. So this is a polynomial, and this is a polynomial. All right? All we're going to do here is distribute. And I know you did this in Math 60 a lot. So you distribute that, what do we get? 3x squared plus 15x. See, you used the properties of exponents there, and you didn't even know it. You took this one times this one. This has a power 1. This has a power 1. I add them, and I get 2. But you applied it, but you didn't really know it because you understand, hey, 3x times x is 3x squared. Okay? And that's how a lot of this is going to be. You really don't need the properties of exponents. You just got to do them. Okay? You're going to do it, but you just don't even know it. You're doing it. All right, let's try. I want to see what other ones that they throw at you. Okay. Here's a negative. I'll put a y in there because sometimes they use y's. I don't know why, but they do. Okay, distribute. What are we going to get? Negative 8y to the second plus 8y. Okay, and we can't combine those, right? They're not like terms. There you go. It's done. Two x squared times 3x squared plus x minus 6. All we're doing is distributing. Okay, we got a monomial and a trinomial. So multiply, multiply, multiply. So our first one, what's our first one going to be? To the 4 plus 2x to the third. Yep, keep going. 12x to the what? Squared. See, again, you're using those properties of exponents, but you don't even know, because you're taking x squared times x squared. Well, that gives me x to the 4th, because I got 2 and 2. 2 and 2 give me 4. All right. 2x squared times x, 2 and 1 give me 3. Yeah. You're just doing it because you don't even. And we can't combine those because they're different. Notice I wrote the highest power first, and the next power, and the next one. Again, you just got to write it like that. And if they reverse things, you just try to write them. And it's not going to be wrong if you don't write in that order, but it's going to help you a lot next chapter. Okay? So just do it that way. All right. Now, let's do this, and then this is going to be the end of the multiplying. So what if we have something like this? So this is a binomial thing. All right? And this is something that I bet you did at one point in time in your mathematics experiences. All right? And it's something you need to know. If you're going to go like on to 95 and so forth, you just got to know how to do this. And it's just simply called FOIL or foiling. All right? And the whole idea is you're going to take this x and you're going to distribute it twice. So you're going to take the x times the x and the x times the 5. So the x times the x is going to give me x squared. X times the 5 is going to be plus 5x. And now I'm done with that x. So now I'm going to distribute the 2. So it gives me a 2x there and a plus 10. Does everybody see where we got that?
Yes.
Okay. Now, almost every single time, the stuff in the middle combines. So that combines to x squared plus 7x plus 10. All right? And that's done. And the reason why they call it FOIL is because you're going to take the first terms. These are the first two. First times outside. Inner terms and the last terms. That's why they call it FOIL. Okay. First times first. First times outside. Inside. Last. Okay. It's multiplication of polynomials, but it's always called FOIL. Okay. So let's do a couple more. It's so important that you're really good at foiling if you're going to move on. It really is. And it's even going to help you next chapter if you know how to foil. If you're a good foiler, you're going to be great next chapter. Okay, first times first. First times last. Make sure you know you have positive and a negative. We're done with the 3x. In terms, last times last. All right, that's FOIL. And all you're doing is double distributing. They should just call it double distributing because that's what it is. But somebody came up with this FOIL idea. And
Is that a minus 4x minus 1?
yeah.
Thanks.
Oh, you're welcome. So once you double distribute or FOIL, again, almost every single time, those inside ones are going to combine. And I don't know why I didn't put a square there, and nobody didn't say anything to me about it. So let's see, we have 12x squared plus 5x minus 2. Questions on that?
I have a question.
Great.
You know where it is the plus, where it's negative 3x plus 8x? Are we always assuming that it's plus?
Nope. No assuming there whatsoever. Let's figure
Oh.
out where the 8 came from. So that's a plus 2, right?
Yeah.
Times a plus 4.
Okay, so
That's
if
a
it was
plus
a
8.
negative, then at that point we would change the positive to a negative.
Right, see how this is a plus 2 times a negative 1 gave me a negative 2?
Yeah,
And this 3 times this 1 gave me a negative 3?
yeah, but I'm talking about this one section. See, if, what happened if that's a negative, right?
Oh,
So
that
then
would
that
be-
becomes negative.
That would be negative. then.
Okay.
Yep.
I have a question. So 12x, oh, it's okay, I figured that the exponent is there, because I was gonna say, why didn't you take the 3 from the 12? But then I remember that the exponent is there, so it's not right.
Okay.
So I got it, thanks.
Yep. So I think, now, you didn't do foiling though in Math 60, right? This is new maybe?
Yeah, this is,
Yeah, this was new. Okay, that's what I thought. So let's try, well, I'm just gonna do a couple more here. 2, did he give me x squared one? No, it's pretty straight, that's what I thought, okay. We'll just do another one anyway. Here, let's put a negative out in front there. That makes it a little bit trickier. Okay, so now we'll do this one. So we're foiling. First times first. What is that going to give us?
6x.
It's got to be negative. Well, 6x squared. Okay? And then we're going to go to the negative 4. What's that going to give us? 8x. Good. Now we're going to go here. So what's that one? Minus, this is a 5. And this is an 8 here. 15. And then 5 times 4. Yep. And again, see those things in them, they're going to combine almost every single time. It's rare that they don't. So 8 minus 15. Yep. Plus 20. Okay.
Would it be a negative 8x though, because it's a negative times a positive? Oh, no, excuse me, I got it mixed up. Never mind.
So again, all you're doing is double distributing. Okay? So let's do one more. I can't leave them alone here. How about this? Now suppose we have one like this. Okay? Here's where FOIL kind of breaks down, but at least the word FOIL breaks down. The double distributing does not. So,
Number 2, is that?
sorry. Yeah, 2. So now we're going to this, and this. So it's going to reach all the way over to that last one. So x times x squared, what's that going to give us?
2x.
X cubed. Okay. X times 3x, what's that going to give us? 3x squared. X times 2 is going to give us 2x. We're done with the x. Okay, this is a perfect example of double distributing. More than the word FOIL. Here, here, here. Now I'm done with the x. There's no more terms to multiply. So now I'm going to take the 1 and move it in there. So 1, 1, 1. 1 times x squared. X squared. 1 times 3x. And 1 times 2, 2. And again, see all the stuff in the middle is going to combine. So we get x cubed, right? Here's a like term. Here's a like term. What does that give us? 4x squared. Here's a like term. Here's a like term. 5x. And then plus 2. Okay? That's the hardest one in the whole assignment. I don't even know if I gave you any of those. All right. Okay, that's it. All done with multiplication of polynomials. Any questions on foiling or that part? Okay, so